of sine and cosine. So what you need to know is understand what they look like and also how to find the amplitude. Okay, so let's talk about amplitude first. So the amplitude of y equals a sine x and y equal to a cosine x represents half the distance between the max and min of functions. Of the functions, I should have said, but that's okay. So the amplitude is equal to the absolute value of the a in front of the sine and cosine. This is the same for secant and cosecant. Now, the other thing they will ask about is, can you find the period? So let B be a positive real number the period of y equals a sine omega x, or w, it looks like a w, and y equal to a cosine omega x is given by, so this is the formula. The period is equal to 2 pi divided by the omega symbol. Same for secant and cosecant. So let me open up the homework so you can see what I'm talking about. Dang it. There it goes. All right. So here's your homework. Let me delete a few for you because some of them at the end are kind of stupid. Okay. This one's lame. Don't worry about that guy. These are very straightforward. I'll leave those. Okay, so let's start with definitions like usual. So let's go ahead and skip that. So look at number 5. So example 5 says, find the period and amplitude. This is from your homework. So example 5. Okay, so we write down the question and I'll switch back. So y is equal to 6 sine of 5x, right? So the amplitude is super easy. You just take the absolute value of the number in front of the sine function, which happens to be just the 6, right? Period is equal to, formula was 2 pi. Yeah, there it is, 2 pi over omega, which is equal to 2 pi over 5. Oh, actually, I have it's supposed to be a 3 in the question. All right. Anyway, is that straightforward? Many questions on number 5? Just using the formulas. Okay, so same thing for 5, 6, 7. Notice how this is a -3. You just take the absolute value, which gives you 3. Okay. Those are more conceptual, which I'll let you read about later. All right, so let's check this out. Okay. These questions are talking about, do you remember how back in college algebra we had vertical shifts, right? And then we had horizontal shifts. So vertical, if F is the original, G is the same thing, but shifted up, right? So this would be shifted up 1, 2 units. So this is just F plus 2. So vertical shift of 2 units from the graph of F, right? So it just talks about those ideas. So let's talk about this though. So number 20, pretty much 20 to the end is just graphs. So I'm not going to force you to do that by hand because that's really annoying. And it's, unnecessary. So why don't you use either graphing calculator or Desmos here. Let me get my calculator out 1 second. So in the exam, I'll make sure that the graphing calculator is turned on. So here we have, where was it? Sine x and sine x over 3. Okay. So here's the two functions, right? So what do the 1/3 or x over 3, same thing, do to the function, right? It transformed the red to the blue. What do you see that is different? Or can you tell what's going on?
It's like less frequent.
Yeah, pretty much, because the original sine has a period, right? That ends right there and repeats itself. So this guy is taking longer to end its cycle. So its period is a lot longer. So it's not repeating itself as fast. So the 1/3 is reducing the period. So if you were to find the period, you would see that it's increasing the period. It's taking forever to finish. So it's technically slower because it has a longer period. Okay, so you just graph these two and pick the right answer. So it's going to be B. So all I want you to do is just graph both and look at what's happening and choose your answer. Okay. Is there any questions on how to do that? All right, so you can see that it's going to be, if I zoom in, right? This blue thing is up there, blue thing's up here, red's there. Just check that it hits the same points. This is more zoomed in, which we could do, but I'm not going to do that. This guy's pretty easy. Literally just plug it in. It was 2 sine, right? So what does 2 do? Here's your, actually, let's do it as is and then do it over here. So times 2 is increasing the amplitude, right? You see that? So you would just choose the one that has an amplitude all the way up until 2. So it has to be C because none of these are starting at the same original spot and going up to 2 except C. So the rest are just literally just plug them in and graph and see what's going on. I do want you to look into these problems up here so you can understand the concept a little bit, but the work itself is really just using your graphing calculator or the graphing website. That's all I'm going to ask about. I'm not going to force you to do it all by hand, like old school. Is there any questions on 6.4? Okay. All right, well, let's move on to 6.5. That's really all I want you to know there. Okay, let me write down the notes for 6.5 real quick. Graphs of tangent, secant, cosecant, cotangent. The amplitude for tangent, which is the only one we're going to cover because cotangent is the same thing as tangent, same rules. Secant and cosecant, we already lumped those together with the 6.4, so you can save some time. So amplitude is equal to the absolute value of A. I meant to put a capital A there. Period is equal to pi over B. So this period is different. So this will be the same for cotangent. Same rules. So example 1, just let's go look at the homework again. Okay. So right here, first few problems again are just concepts. Notice I hear they're going to ask you for the period. So it's just going to be 2 pi over 1 because there's a 1 in front of there, which gives you 2 pi. So nothing to do here. Let's see, 1 second. Problem 4. Same kind of deal. Let's go ahead and do problem 4, I guess. Find the period of y equal tan x. So we said that the number on that w, right, or b in this case. So that's going to be pi over 1, which is pi, right? In this case, b was 1. So let me switch back. Okay. So if there's no number on there, you assume it's a 1. So you just do pi over 1. That's all there is to it. Same thing for cotangent, which was number 7. Okay. Is that straightforward?
Where did you get 1 from?
It's the coefficient of x. There's a right here, b is 1. When there's no number there, it's assumed to be 1. Okay, so after that is just graphing stuff. So literally plug this into your grapher and pick the right answer. So there's nothing really to do. Period will be just like how we did it before. 2 pi divided by the number. Sorry, pi divided by the number. Which will get us that period here. Excuse me. Okay. Same thing here. So for example, 1/2 cotangent pi x. Minus 1/2, yeah. So it looks like it's going to be this guy, right? So just pick the right answer. And then divide the pi by pi, which will give you a 1 from this formula, right? You see how the coefficient was pi, so it'd be pi over pi for number 9. Right? So that's why the period is 1. Okay. Anyway, so those sections are pretty chill. I'm not really gonna force you to do it by hand. I'm hoping you can get through it in like an hour or something. Anyway, do you guys have any questions on graphing? So the only thing you need to remember for 6.4 and 6.5 is, can you find the period and amplitude for sine and cosine, secant, cosecant? Those are all the same way. And then find the period and amplitude for tangent and a cotangent. You can use your graphing calculator, Joseph, or you can use the Desmos website. And I'll make sure that you can access that website on exams as well. Also, you can check out calculators if you want to on campus, probably when we get back on Monday or something.
Will we be on campus Monday?
Yeah, we should be. Should be Monday. No, I'm 90% sure we will be, unless something crazy happens. Never know anymore. We'll see. So that's all for chapter 6. So we should start talking about exam 1. Let's see here. Look at the schedule. Okay. So it says that we should have the exam on the week of Valentine's Day. So I'm thinking next week we will do 6.6 and then review. And then
are you just gonna open the test online, or are you gonna take it in person?
I'll leave it open. You can take it whenever. I'll give you a week to do it. So
can we review before we do 6.6?
Yeah.
I'll rip that Band-Aid off. Is that cool?
Yeah, that's fine. We'll do. We're gonna review first. Don't worry about it. Yeah. So Monday we'll probably just do review, and then Wednesday we'll do 6.6, and I'll open the exam up, and you have until the 16th to do it. Okay. So you have a week from the 9th. It may already be open. I need to check actually, let me check right now. Yeah, I need to set this up. I need to put a due date on here. So there'll be a due date starting probably Wednesday or something. Right now there's no due date, but it is unlocked. So you could take it earlier if you want to. You guys have any questions? Because that's all we have for today. So we can do some homework, or if you want to head out, you can. If you have any issues, let me know. We can deal with that today.
Given that we've kind of covered everything at this point, and I kind of have been like belaboring homework, I'm probably going to take a crack at it and then bring any questions I have to you Monday, if that's all right.
Yeah, that sounds good. It's a good idea.
I know we have the exam coming up too. I want to just kind of get it all together. So thank you very much. I will, by the way, in between now and then, I may email you if I have questions or whatever, but I don't think or I'll leave like, could you see the notes when it says like ask my teacher, or like, do you get that?
I don't check those right away. You can just send me a remind and let me know, like, hey, I'm stuck on this number. I can check it out.
Okay, cool. Sounds good. Thank you very much.
Yeah, I'll see you later. All right, Joseph, I think no one has questions. Let's figure out what's going on here. So let's go through the steps one more time and see what's going on. So you did click, so you went to here, right? And you click this link, correct?
Yes.